Today, we are diving deep into the world of data. We're going to find out how we can take a chaotic jumble of raw numbers and turn it into crystal clear insights, all with a little help from a super powerful Python library called Numpy.
I mean, seriously, how do companies predict the next big thing? How do scientists find brand new patterns in their research? Well, it all starts with turning all that digital noise into a signal you can actually understand. And today, we're going to pull back the curtain and show you exactly how it's done. So here's our game plan. First, we'll get a handle on our raw material, data itself. Then, we'll walk through the universal process for cleaning it up. We'll grab our statistical compass to find our way through the numbers, and then we'll introduce our powerhouse tool, Numpy. Finally, we'll put it all into action. Let's get into it.
All right, first things first. Before we can start working with data, we've got to ask the most basic question. What is it, really?
Think of data as raw ingredients. A collection of facts, figures, and records. On its own, it's not really information yet, but it has all the potential to become it. It's just the unorganized stuff of our digital world, waiting for us to give it a purpose.
So, why do we even bother collecting all this stuff? Well, simply put, data helps us answer really important questions. For instance, a streaming service looks at viewing data to recommend shows it thinks you'll love. That improves its service. Or a city planner uses traffic data to figure out where to build better roads. Data is basically the evidence we use to make smarter decisions.
All right, so we have our raw ingredients. Now, how do we actually turn them into something useful? We need a process, a kind of recipe. And that's where the data processing cycle comes in.
This cycle is our roadmap. It takes us from that messy, raw data to clean, usable information. It's a structured set of steps that brings some order to the chaos and finally makes our data meaningful. And here it is. This gives you a great bird's-eye view of the whole process. As you can see, it's a four-stage journey: input, processing, output, and storage. And this isn't some one-off trick. This is the standard foundation for pretty much all data work.
Let's break it down real quick. First, we collect all our raw data in the input stage. Next, during processing, we clean it, sort it, and transform it. Then, we present all that useful info in the output stage. And finally, we save everything for later in storage. See? Pretty straightforward.
Okay, so we've processed our data into information. But a giant list of numbers still isn't really an insight. To understand what the information is trying to tell us, we need a few statistical tools. Think of these as our compass, helping us navigate the data and find our way.
Our first and most common tool is the mean, which most of us just call the average. It's like finding the center of gravity for our data. So if you wanted to know the typical price of a house in a neighborhood, you'd start by calculating the mean.
And calculating it couldn't be simpler. You just add up all the values in your data set and then divide by how many values there are. In this example right here, we add 8 numbers together and divide by 8 to get our mean of 55.75. Easy.
But just knowing the center isn't quite enough. We also need to know how spread out everything is, and that's where standard deviation comes in. Imagine two cities with the exact same average temperature. Sounds similar, right? But one might have mild seasons all year, while the other has blazing hot summers and freezing winters. Standard deviation is what tells us that difference.
And whoa, okay, don't let the formula scare you. We're not going to get bogged down in the math today, but it's good to see what's going on under the hood. This is just the formal, mathematical way we measure how spread out our data really is.
Okay, so we get the data, we get the process, and we get the basic stats. Now, let's bring in the powerhouse tool that does all of this heavy lifting for us and does it incredibly fast: Numpy. Numpy, it's short for numeric Python, is basically the go-to library for any kind of scientific computing in Python. Its specialty is working with arrays, which are just these super efficient grids of numbers designed to handle huge data sets and complex math at unbelievable speeds.
So what's the secret sauce? How is Numpy so fast? Well, it's because its arrays can only hold one single type of data. Imagine a toolbox where every single wrench is the exact same size. You could grab any of them without even looking. That uniformity is what allows for these massive speed optimizations. Okay, theory is great, but let's see how this actually works. What do these arrays look like, and how do we even make them? This is a perfect visual breakdown. A 1D or one-dimensional array, that's just a simple list of numbers, like a single row. A 2D array is like a spreadsheet with rows and columns. And a 3D array, that just adds another layer of depth, like a cube of data.
And Numpy gives you a ton of super easy ways to make these things. You can just convert a regular Python list, or create an array of evenly spaced numbers, or even instantly whip up arrays that are pre-filled with zeros or ones. The main takeaway is that it's incredibly flexible.
All right, this is the moment we've been building towards. We've got our concepts, we've got our tool. It's time to see the big payoff and put Numpy to work.
So remember all that talk about mean and standard deviation? Well, check this out. Numpy has functions for them built right in. You don't have to write out any of those long formulas yourself. You just call a simple function, and Numpy does all the heavy lifting in a split second.
And boom, this is the power of Numpy in action. Just look at this code. We create an array of numbers, and then, with one simple command for each, we calculate the mean, standard deviation, variance, you name it. All of that complex math is boiled down to one easy-to-read line of code. Now that is efficiency.
So there you have it. We've gone from raw, messy numbers to powerful insights. We've seen how the data processing cycle gives us a roadmap, how statistics act as our compass, and how Numpy provides the high-speed vehicle to get us there. The path is clear. The only question left is, what story will you tell with data?